Good morning, my YouTube viewers. It's Crystal here. I didn't get to make a video yesterday because I was sick over the weekend. I had the flu, and yesterday afternoon I did go to work in the morning, but I felt like I didn't want to make a video until I felt better. So I'm feeling better, so I'm making another video. This video is how I achieved my 43rd bronze medal with Kaggle's community competition, or no, it was a playground competition. And this was on Playground Competition Season 3, Episode 24, and it's Jax Linear Regression, and it's going to be no norm, so that's going to be no normalization. I did get a comment in addition to the bronze medal that I got. I got a comment. Somebody said, really nice work, well done. Jax is not seen often here. Now, Jax is a library that is made by Google Brain, I believe it is, and it's supposed to be for research purposes. So I didn't even hear about Jax until several weeks ago, and then I thought, oh well, I'm going to start learning Jax. Google also writes TensorFlow, so people tend to use TensorFlow more, and the reason why they use TensorFlow more is because it has more documentation. Jax doesn't have as much documentation, except for the fact that Jax is written very similar to the NumPy API, and so a lot of the same functions in NumPy can also be used in Jax, but not all of them. For example, the random number generator is different, and another example is the fact that the Jax arrays are immutable, and because the Jax arrays are immutable, they're more difficult to work with. So here we go. Here's this competition that I wrote in Jax, and so I want to just go over it with you since I got a bronze medal for it. First thing we're going to do is we're going to predict our problem statement, and it's predict the probability of a smoker status to determine whether they're a smoker or a non-smoker. Another thing that I'll do is I will leave a link to the Jupyter Notebook in the description box, so if you want to follow along with me, you can. After we've gone over the problem statement, then we're going to go over the import library. So we're going to import Jax, which is what we're going to use to create the linear regression model. Then we're going to go over to pandas, which is going to upload the CSV files and convert them to data frames and process data. We're going to import OS, which is going to go into the operating system and retrieve the files we're going to use. We're going to import sklearn, which provides machine learning functionality. We're going to import matplotlib.pyplot.splt, which visualizes the data, and we're going to import seaborn as SNS, which statistically visualizes the data. So after we have imported our libraries, we're going to retrieve the CSV files with the OS function, so you can see how that's done here with a for loop. Then I set it up to where you can view all of the columns of the pandas data frame. pd.setOption brackets display.maxColumns none. Now we're going to use pandas to read the CSV files, and we've got 3 CSV files being train, test, and submission, and they're going to be converted to data frames. Now we're going to check the train file. You see it's 24 columns of data, and we can see all of the 24 columns, the final column being smoking, which is your target. But what we're going to do is we're going to predict on probabilities. We're not going to predict whether they're smoking or not. We're just going to predict on the probability that they're going to smoke. We check info. You can see all of the columns of data are numeric, so that means you don't have to impute anything. We're going to check for null values. You see there's not any null values. Sorry. When all of the columns of data are numeric means we don't have to encode anything. Sorry about that. And then now we check that we don't have any null values, so that means we don't have to impute anything. We check our test. So we've got 23 columns in the test file. The test file does not have the final column of smoking because that's what we're going to predict, but we're going to predict on the probability that they're smoking. We check the all the columns. We find out that they're all numeric, so that means we don't have to encode anything. We check for null values. We don't have any null values, so we don't have to impute anything. And then we check the submission file, and this is similar to what Kaggle wants to see when we submit our submission. We're going to remove the ID column. The reason why we're going to remove the ID column is because in Pandas, it automatically indexes every row, so you don't need that. We're going to analyze the target, which is the smoking column. So you can see you got a lot of zeros and not so many ones. That means more people are non-smokers than there are smokers. We're going to check, do a heat map, and so you can see that some of the columns of data are closely related. But I'm not going to remove any of the columns of data, because I used to remove the columns of data, but I found out that it doesn't actually improve your score that much, or if at all. In some cases, it actually degrades the score, so that's why I'm not going to do it. Now we're going to define the target. Target equals train.pop smoking. So that means the smoking column is popped out of the train and it's put into target. Now what we're going to do is we're going to standardize the data, and we're going to convert target, train, and test to Jax arrays. Then we're going to standardize the train set. Well, mean equals train.mean, std.dev underscore dev equals jnp.std train. Train equals train minus mean over std dev. And then you've got your train, and then we're going to do the same thing with your test. And so, exactly the same code, it's just you're doing it with the test data frame and not the train data frame. And now what we're going to do is we'll define the dependent and independent variables. Y equals your target, X equals train, X test equals test, and then we print the shape so you'll know what the shape is. Now we're going to use sklearn's train to split the X and Y variables into training and validation sets, and you also want to print the shape. Make sure you know what your shape is. Now we're going to define our linear regression model. And so with multiple linear regression, you've got 3 functions in it. You've got the init function, which initializes your variables. You've got the fit function, which trains the data. And you've got the predict function, which predicts on the data. And then what we're going to do is we're going to define the model as multiple linear regression. model.fit x train y train. So we're going to train the data and we're going to make predictions on the data. Y pred equals model.predict x val. So you've got your predictions. And then what we're going to do is we're checking on our root mean squared error. Our root mean squared error is 0.43. And we use matplotlib to plot a diagram of the regression line against the actual values. So you can see that there. And now what we do is we're going to use Seaborn to plot y pred. So you see y pred is between less than 0 and over 1. Now we're going to make predictions on the validation set, or on the test set. We're going to make predictions on the test set. So it's exactly the same. Predictions equals model.predict x test print predictions. Now we're going to use Seaborn to create a histogram of the predictions, and so you can see it's less than 0 to over 1. And then what we're going to do is we're going to clip the predictions. Predictions equals jnp.clip predictions. So we're going to clip everything from 0, make it everything 0 to 1. So you can see here, this is where your predictions have been clipped. Now we're going to submit our predictions. So submission smoking equals predictions. Submission.toCSV is submission CSV index equals false. Submission equals pd.read CSV. Submission equals .csv. And then we check our submission. And then so this is what I got a bronze medal for. And when we submitted our work to Kaggle, I got 80%. So I still wasn't my highest score, but I guess Kaggle liked it because they gave me a comment and gave me a bronze medal. I'll be glad when I start getting silver medals. That'll be really good when I get silver medals. I have to improve my score, but you can see that I've been working on this competition question a lot, trying to find different things to do to improve my score, but I haven't been able to get higher than 83%. So I'm going to go ahead and conclude this video because I've covered the code for how I got my 43rd bronze medal. And I'm going to leave a link to the Jupyter Notebook in the description box so you can follow along with me if you want to. So thank you so much for my subscribers for supporting my channel. If you like my videos, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you so much again for watching my video. I look forward to making more videos for you in the future.